Okay, nice. So my name is Tasos Zafiropoulos. I'm the technical manager of the NEPHELE project. And in this presentation, I'm going to give some, let's say, a quick overview, some highlights of what we are doing in NEPHELE as an approach for the projects active in the meta-orchestration area, and provide some details specifically for what we request for the first open call in terms of artifacts that can be produced. So a very, very introductory slide is this one, where we show what is the overall approach that we envisage in the NEPHELE ecosystem. In NEPHELE, we consider two main outcomes. The first one, that is, let's say, the main artifact related to the first open call, has to do with an IoT and edge computing software stack. So we develop a software stack that enables us to virtualize IoT devices so as to provide virtual counterparts of IoT devices with the objectives to solve a lot of interoperability and convergence aspects, considering different way of communication with the IoT devices, but also convergence aspects of IoT technologies with cloud and edge computing technologies, and we will see more as we progress. This is the first part. And then the second part is a synergetic meta-orchestration framework where, given that we have virtualized instances and applications as application graphs as software, we want to provide an orchestration approach that we can manage the life cycle of these applications, including in the applications the virtual counterparts of the IoT devices, over resources that are distributed across the computing continuum, so considering IoT resources, far edge or edge resources, and cloud resources. And to do so, we follow what we call a system of systems approach, where a main entity is responsible for the life cycle management of the overall application during the deployment in the continuum. However, the control is distributed in various, let's say, nodes that can manage local or even global, take local or global decisions. And this have to collaborate, so to form a kind of a synergy to support the orchestration part. This is the two main things that we envisage in NEPHELE. As said, in our today's discussion, focus is mostly in the IoT and edge computing software stack. So what we have here, we have the definition of a virtual object. For us, the virtual object is the virtual counterpart of an IoT device, like this part in the figure, or it can be the virtual counterpart of a cluster of IoT devices of similar type. So here we have different devices of similar type connected through a gateway and abstracted in a virtualized instance in the edge part of the infrastructure. In this way, we can support different types of communication protocols for interaction with the IoT device. We can support unique ways for providing authentication, authorization actions, and we can also support in the virtual object part the development of generic functions that can be applicable to support different functionalities that are mostly supported today in various, let's say, IoT middleware platforms. So we have the concept of the virtual object, and moving one step further, we have also the concept of the composite virtual object. So the composite virtual object enhances, let's say, the functionality of the virtual object. So it can provide some extra functions that it can be domain specific. So if I have specific sensors for monitoring, I don't know, energy consumption in smart buildings, maybe the composite virtual object do some kind of aggregation of the data for energy and apply some rules and give some recommendations. This could be part of a composite virtual object. The composite virtual object can also undertake the role of a digital twin. So I want to provide specific functionalities to be emulated or simulated, considering data coming from the IoT devices. So this can be implemented also here. And I didn't mention that the composite virtual object can fuse data or manage actions coming from one VO, virtual object, or for multiple VOs, multiple virtual objects. So in this case, we have also kind of data fusion. So we need kind of context awareness, probably reasoning of the information to take decisions. So this is the main artifacts where we deploy a software stack. And in the upper level, in the upper level, we have interfaces, orchestration interfaces, where these virtual objects or composite virtual objects can be managed by applications, can be, let's say, not managed, can be interlinked to applications. So at the end, I have an application developer. We follow a microservices-based approach. We develop an application graph. Okay, so we declare the application components, the microservices, and the dependencies that they have among each other. And this graph is interlinked with, can be interlinked with composite virtual objects or virtual objects. So VOs or CVOs, in short, I will call it like this from now on. So at the end, this is a graph that can combine VOs and CVOs. And at the second phase of the project, moving back to the previous slide, this graph should be orchestratable across the computing continuum. So on the left part of the screen, we have the layers of the virtual object stack. So we have three layers. The physical convergence layer, where we try to implement functionalities related to the support of different communication protocols, for instance, HTTP and MQTT, the application of proper authentication, authorization, and general security functionalities for the interaction between VOs and IoT devices, but also among VOs or between VOs and CVOs, and also networking functionalities. So in the way that we can manage ad hoc nodes, support clustering functionalities. We consider time-sensitive networking also functionalities. And where applicable, when we speak in an end-to-end way, we also consider SDN, software-defined networking functionalities that can be supported over the infrastructure and facilitated by VOStack. In the middle, we have the backend logic layer, where here we try to support different type of what we call virtual functions. So it's kind of software that serve a specific application need and can be implemented in the form of a function. So here we may have generic functions that can be applicable in different type of devices and probably application domains. For instance, time series analysis, outliers detection, time series decomposition techniques, forecasting can be applicable in any sensor providing time series data. But we can also have specific functions for specific type of devices, considering, for instance, also kind of where we need to have image collection and analysis. This should be also functions related to this. Here we formulate the different type of actions that can be requested, considering existing specifications, and we also consider a way to be able to support alerts, notifications, conflict resolution functionalities. And then moving to the upper layer, we have the edge and cloud convergence layer. And here we focus a lot on the interconnection of VOs and CVOs with the application graphs. So we need a lot to have orchestratable services. Focus a lot also on semantic interoperability. So we want to develop solutions that can support different semantic protocols for interaction with the application. So an application developer may adopt a specific semantic model. So the VO and CVO should be able to incorporate it. And we consider here the basic semantic models around. And also aspects related to multi-tenancy and data sharing and exchange among the virtual counterparts. To achieve so, we have defined different interactions that can be supported by the virtual object. So interaction with the IoT devices. we consider a storage entity that is binded to its virtual object and can store both time series data, but also that data related to the configuration of the EOT device. We have interaction with microservices, other application components, and other VOs. And for sure, we have also orchestration interfaces that we can manage the deployment and the lifecycle management of the virtual objects. Coming to the software implementation and release that is available within the first open call, we have two releases. The one is mapped to the specifications coming from Open Mobile Alliance lightweight machine-to-machine communications, so OMLW M2M, where we have implemented the various interfaces, and we have the way that we can manage through the virtual objects the various objects that are defined in each EOT device, and have the orchestration interface toward the application components. And the same applies in the W3C Web of Things specification, where again we have virtual objects interacting with EOT devices in different modes, depending on if we can have just reading functionalities, or we can also go back with actions to the device. And based on the exposed and consumed things defined in the W3C Web of Things specifications, we have implemented the relevant part in VO stack, and we are trying to build over it. So, for instance, in this case, as mentioned, we can have two types of deployment. In type A, we consider EOT devices that have computing capabilities, so they can host part of the software, and they can get also actions. So we define specific exposed interface and consume interface also with the device and between VOs and CVOs, and then for the application part. And in the type B, the sensor is more dummy. It can provide data to the VO, and this data then can be consumed and exploited by the application part. Now, given this, let's say, software release, that it's a stable release, however, release that is also active, and there's a lot of work in progress in the project, so it will be live repositories, live software repositories. We want to introduce functionalities that complement and extend the specific software stack based on ideas that will be proposed and your work there. And we consider this that will be of very high value for us, for both validation and extension of the proposed artifacts. We focus on open source releases, so both releases are made available as open source. So whatever we get, we want also to be made available as open source as part of the stack, with the appropriate, for sure, credits to the developers. So we have these four main categories, and I will go allocate a very few minutes in each one of them. So we have the development of virtual objects and composite virtual object along with a set of functions. So maybe an applicant can focus on provided VOs and CVOs for a specific domain. So deploy based on the descriptors specific instances of these VOs, but also develop some functions that can be generic enough or specific to the domain to accompany this word. So this will come as a package, let's say, that can be introduced in VO stack. We consider the development of digital twins. So here, someone has to define the main role of the digital twin, the type of devices that it has to interact, and the type of functionalities that the digital twin offers. Again, we are domain agnostic, so it can be applied in any domain based on your interest and your experience. We focus a lot on network and security management mechanisms for the VO stack. So as said, solutions that can extend network functionalities for management of the EOT nodes, a cluster of nodes, time-sensitive networking functionalities, reactive routing functionalities, but also SDN solutions active to the IoT domain can be applied. The same applies for security. We have some initial security implementation for authorization, authentication of the interaction between VOS and IoT devices, but ideas for extensions are also very welcome. And last but not least, semantic interoperability mechanisms. Again, here, we would really like to see solutions that can provide some way that the collected data that now are based on W3C Web of Things or OMA can be interoperable. So we can have some semantic translation mechanisms applied over them. So this is also kind of reasoning techniques. This is also very welcome. A few more details per action, but I think I have already mentioned. So in the first part, we have development of VOS and CVOS for IoT devices that can be applied in a specific industrial domain. Okay, we consider different domains. We also consider the area of robotics, where we have extra challenges to interact with devices. A set of virtual functions have to be implemented to support various functionalities. And we also foresee a need also to be able to manage video streams and or images. This is something that we would like to extend our framework with these capabilities. We also envisage to work on this area, but also solutions around this are also very welcome. Okay, as said, the digital twin part is a hot topic, and here we would like to see solutions. However, we would like to see solutions probably incorporating VO and CVO concepts, but let's focus on some concrete functionalities that the digital twin will provide. So some mature solution that can fuse specific type of data, process them, make some extra functions, support some extra functions, whether are simulation or not, and provide some outcome. And this is also very welcome. Network management and security management mechanisms, I also mentioned it with a different type of functionalities that can be supported for the networking and the security part. So I'm not repeating a lot. And last thing, semantic interoperability. We have indicative models that we consider, but again, this is not restricted. If someone works with specific semantic models, you can propose solutions. However, consider that these models have to have some recognition and some applicability in a wider perspective. And also, we consider solutions that tackle the interplay between VOS and IoT devices. So, management of ML workflows, machine learning workflows in the VOS and the IoT devices, as well as semantic data management and reasoning techniques, maybe over the collected data, are also welcome. And I will be very short because Diana will explain much more for the process. We have the guide for applicants. We have specific software repositories where the software is made available, and they are accompanied with documentation. But specifically for the Web of Things version, we have a documentation also in this website. So I think that's all for me. Thank you very much for the attention. And I give the floor to Diana to provide more details for the process, and also then to have some time for discussion.
Perfect. Thank you, Tassos. And so you see my screen, right? Can someone confirm?
Yes, Diana.
Yeah, yes. Okay, perfect. Okay, so hi everyone, and thank you for joining today. My name is Diana, and in NEPHELE, I'm responsible for the open call management. So let me just see 1 second here. Yeah, okay. So my presentation will be just a short overview of how to apply to the first open call and it's not going to be as technical. But still, some main points that you should consider when applying for the open call. So let's start with the basics. Most probably, most of you here have already visited the application website, but if you're new to the open call, then the website to apply is presented on this slide. And the deadline to apply to the open call is the 10th of January at 5 p.m. So you have more or less a month left to submit your application. And please be aware that failure to submit the proposal on time due to whatever reasons means that we will not consider your application. So do apply ahead of time. So before submitting your application, you should, of course, carefully read the open call documents, which are the guide for applicants and also the frequently asked questions. And all these documents are linked to the open call website, and they will help you guide through the open call process and will help you basically create a successful application. So before applying, make sure that you tick all the boxes regarding the admissibility and eligibility criteria that are presented in section 3 of the guide for applicants. So there are 3 different sub-chapters that you need to look at. So the first one is who are we looking for? So you must either be an industrial SME or a mid-cap established in the listed countries. Then the second sub-chapter identifies the types of activities that we're funding, and you just heard the presentation from Tassos explaining all the activities in more detail. But still, read it carefully, pay attention to the focus areas, and of course, make sure that you demonstrate expertise and experience in at least one of the defined fields, because that's also necessary for this OPAL. And then finally, there's a third subchapter that details basic criteria that you need to fulfill, such as the application needs to be in English language, submitted on time, there should be no conflict of interest with the consortium of NEPHELE, and so on. So then, okay, there's not, oh, yeah. Okay, now let's have a quick look into the application form itself. So the application consists of 10 sections, as you can see on the screenshot. You'll be asked to provide some basic information, then information about your company, the proposed project, and finally some provisions that you should review. So basically sections 8 to 10 is where you have to tick some boxes. So it's not no writing involved there. And if you would like to add any teammates to contribute to the forum, then you can do so by adding contributors. So you can click on the upper left corner of the screen. There is a button, add a contributor, and then you can all together work on the application form. And here's some quick tips for the application process. So each applicant can submit only one proposal. If you submit more than one, then only the last submitted proposal will be evaluated. Then you can always come back to the application form and edit it before the deadline, even if you have submitted it already. You can add contributors, as I already mentioned. And then keep in mind that you can submit your form only after all the required fields have been filled out. Okay, so what happens after the open call closes? Once the call closes on the 10th of January, the evaluation will kickstart in like right after. And it's almost a 2-month-long process, so you will not be hearing from us for a while. And at the end of February, we will have the list of finalists, and those will undergo a formal check where we will check the legal status of your company. For instance, if you actually are an SME or a mid-cap, as you're stating in the application form, and any other relevant aspects. And those who have passed the formal check will then sign sub-grant agreements in mid-March with the NEPHELE consortium. And finally, at the beginning of April, the support program starts. And now just to give you a brief overview of the evaluation process itself. So it consists of the steps indicated on the slide here. So basically it's 4 steps. So we will start with the first admissibility and eligibility check. Then our technical partners in NEPHELE will do an in and out of scope screening to see if the applicants have the relevant experience and if they target relevant focus areas. After that, external evaluation kicks in, where external experts will evaluate the proposals and will give scores. And as a result of this stage, the proposals that receive the highest score will be discussed during the consensus meeting, where the NEPHELE partners then will decide on the list of finalists. And as I mentioned earlier, the process will take up to 2 months, counting from the open call deadline. So you'll have to be patient here. And we will have a Q&A session right after my presentation. But if you still have any questions, then you can always reach us through the email indicated on the slide. So it's nephelehelpdesk@fundinbox.com. And you can also, or you can post your question on the Q&A space in the IoT community. So that's it for me. Good luck with your proposal. And I think we can start with the Q&A now.
Yes, thank you, Diana. I'm leaving here in the chat both the email and the help desk link.
Yeah,
in case
that's
you
perfect.
Want to come back later. So either you can type your question in the chat or in the Q&A section, or you can raise your hand. I will give you the floor. Okay, so we'll wait you a couple of minutes to think of your questions. Don't worry.
Just to say that for all applicants, it is nice to go a little through also the GitLab repositories. We host the software in Eclipse GitLab, Eclipse Research Labs GitLab. You can find there, I think it's a good exercise to experiment with the software and maybe also try to make a deployment to see how it works. We will be around to answer any question that may arise. And as said, it will be a live project, so some things will also be provided, I don't know, not very, very soon, but as we progress also on our side, some more information. So for any question or clarification you may need now or during the process, we will be around with the colleagues from Funding Box to support. Just would like also to highlight it.
Okay, we have a couple of questions. Is there any minimum size for the SMEs that will apply?
So the SME, it's all in the guide for applicants, where we refer to the headcount. So it's basically about the headcount, like how many people you have employed in your company. And it's less than 250. All this information is in guide for applicants.
Okay,
I hope.
thank you.
Yeah.
Thank you, Diana. So Luca wants to know, I see your reference. I see that your reference implementation is based on Python. Do you have interest in having a second independent implementation in another language?
Yeah, okay. This could be also an option, given that what we have done, we follow for the Python part, we follow the developments in the W3C Web of Things community. And actually, we started from a Python implementation of the Web of Things, and we build over it, we extend it, and we add extra functionalities. It is of high interest to extend this software stack with extra functions to give it as a advanced version. However, solutions that can also implement the stack in different languages are also welcome. Yeah.
Thank you. So Cristiano is asking about the TRL. So the guide for application mentioned that the solution proposed needs to be at least TRL4. Can you elaborate on that? For example, I assume that there is going to be some innovation in integrating new software to be coded. Already existing solutions into BOs and COs. What should be TRL4? The whole proposed project or just the technologies to be integrated?
Okay, I think for TRL4, so we have validation, let's say, in laboratory environment, given that we give a software stack where you communicate with specific type of devices, so real hardware and software deployed at the edge part of the infrastructure, building a solution that can be validated in laboratory environments should be not hard. So I think TRL4 is easy to achieve, given that you start from a specific software stack that is there. We have implemented proof of concepts with interaction with specific type of devices, and we want to extend it. So I would say that the overall solution can be from TRL4 and maybe higher, depending on the solution. But I won't be afraid to have a TRL4 in the solution, given the starting point.
Thank you. So we have more questions on the TRL. What kind of TRL starting evidence is needed for a digital twin project?
Again, I think the answer is similar. A TRL around 4 or higher is welcome. For me, we do not need to see a solution that is operational on a business environment. Okay, we want to see a solution that is well binded to the virtual object stack, and it can interact with specific type of devices in the digital twin concept, and it can give added value in terms of functionality. So I do some specific simulation, processing, emulation that gives added value, taking advantage of the composite VO. So TRL 4 or 5 should be fine also for this. Trying just to give the perspective.
Thank you. We have one last question. Is it required to extend the provided GitHub project, or we can develop a standalone application, but in the scope of the project definition?
The requirement on our side is whatever you develop to be able to be made available as open source, because the objective of the open call is to enrich the functionalities of the open source release of the virtual object stack, and also create a community that can work around it and probably take advantage of it in the various domains in the future. So we do not have a very strict requirement on how the code will be released. We can also support on integration of part of it in the future. However, the strict requirement is to have open source releases.
Thank you very much, Tassos and Diana. Thank you, everybody for coming to the Q&A. And remember, you can still write us in the helpdesk community or in the email. We will be available until the end of the application. And we hope you the best luck for your applications. Thank you very much for coming, everyone.
Good luck, everyone. Thank you.
Good luck, and thank you very much.
Have a good morning. Bye.
Bye-bye. Bye.
Bye-bye.